Okay, we have just gone through the installation, the onboarding process, working through what we're doing to make Federation happen. Now that we've got our global managers, our active and standby global manager, and we've got our local managers onboarded, what are we going to do with Federation? Well, one of the things we might do is networking. We may want to stretch networking for multiple locations to have the same exact network domains, right? The same layer 2 stretched across multiple sites, the same routing stretched across multiple sites. In other words, treating multiple sites potentially as one big logical site. And so we can stretch our gateways. We can stretch segments. That means that, well, since we can stretch gateways, I suppose, that means that we can also stretch some services. So some things are Federation capable. Now, something to think about, something to remember is not everything in NSX is Federation aware at this point, meaning that not everything works in the context of this global federated infrastructure. That doesn't mean it doesn't still work locally inside a site, but, for example, the intrusion detection and prevention system, that's a local thing. So we want to keep that in mind. Not everything is federated yet. But gateway firewalling, distributed firewalling, right? The next video we talk about will be all about security stuff and what we can do there. DHCP, DNS, right? Many of these services that we've already talked about, many of these things are already Federation capable. So we can stretch networks. We can stretch gateways is really the big thing we're looking at. And attaching a segment to a stretched gateway will automatically stretch that segment to equal the span of that gateway. So here I've got T0 and T1 stretched gateways. Those both span locations A, B, and C. Well, when I attach a segment to the Tier 1 gateway, or I attach a segment to the Tier 0 gateway, well, those segments automatically get stretched across locations A, B, and C because their attached gateway is stretched across that span. Now, to get traffic from one location to another, we have a construct called an RTEP, or a remote tunnel endpoint. Remote tunnel endpoints exist on our edge nodes, only on our edge nodes, and only in the context of Federation. We're going to set up these remote tunnel endpoints to provide basically a site-to-site overlay network so that we can send traffic back and forth. But not all of my global objects have to be stretched, do they? I may want to create objects, gateways and segments and things, create them and have them exist only in a single location. So I can do that. I don't have to stretch everything. I may not want to stretch everything, even if I'm using stretched networking. I may have some very specific and targeted use cases for that, and I want most of the rest of my networking to be more or less site local, depending on what your needs are. So I can create non-stretched objects and leave them in the context of a data center. And I can do this through Global Manager, just like I would do it through any given local manager, right? Simply by selecting just location A in this example for my Tier 0 and Tier 1 gateways. But I can stretch things as they need to be stretched. And I don't have to have everything stretched to the same scale, right? I can put networks, I can put gateways where I need them. I can stretch them as far as I need them, and everything will be fine. When we're looking at this, we might want to think about interconnectivity, right? My Tier 1 gateways are always going to need to connect to a Tier 0 gateway, right? Because we need that upstream, downstream connection. Well, the Tier 0 gateway that I attach my Tier 1 to has to meet or exceed the span of the Tier 1 gateway. In other words, the Tier 0 gateway has to provide coverage in all of the places that the Tier 1 gateway exists. So we look at the diagram here. We look at what we have going on this picture. I have a Tier 0 gateway that stretches across locations A, B, and C. Now, because of that, we're providing coverage across all three sites. Now, I can have my not stretched Tier 1 gateway attached to my stretched Tier 0 gateway because the Tier 0 gateway covers location A. I can have a tier 1 gateway that stretches from location B to location C attached to that same tier 0 gateway, because that tier 0 gateway provides coverage of locations B and C. I have a tier 1 gateway that stretches locations A, B, and C, just like the tier 0 gateway. I can link that tier 0 gateway to the big tier 1 gateway, because my tier 0 gateway covers locations A, B, and C, just like the tier 1 gateway. In other words, the tier 0 gateway in this example meets or exceeds the span of each of the connected tier 1 gateways. So this is something I want to think about, right? My tier 0 gateway, if it's going to be a common device, should have the largest span of all of the network objects. Now, if we want to look at how not to do things, this is a case of my tier 0 gateway only spans location A and B. The tier 1 gateway topology is exactly the same as what we just saw. But since the tier 0 gateway only spans locations A and B, most of the connectivity is no longer functional. It's no longer valid, because I have gateways in location C, and the tier 0 gateway doesn't cover location C. Now, here we're looking at single location gateway deployments, single location tier 0 gateway deployments, and you know, I can build a tier 0 gateway in Global Manager that only spans a single location. That's easy enough to deal with. But something else I like to talk about here is the fact that my HA mode is independent of span, right? The tier 0 or tier 1 gateway HA mode, the active or active standby HA mode, is going to be a thing. It's going to be something that we have to configure whether the gateway is stretched or not. And that active or active standby configuration is going to be relevant inside a given location, right? It works just the same as what we've already talked about, right? Where active means we're using both service routers, or as many service routers as I have, however many edges I have. Active standby means I have one active service router and one standby. So it functions exactly the same as it has, as we've previously talked. Federation doesn't change how active and active standby work. It just means that we have to think about it inside a single location. Now, my tier 1 gateways, inside a single location, my tier 1 gateways are going to work just like they have already, right? Just like all of the tier 1 gateways we've already talked about. And again, they're only going to be active standby. But when we get into stretched gateways, when we get into spanning gateways across multiple locations, we then have to start thinking about not only high availability of the gateway, but also whether a given location is primary or secondary. Primary locations handle the north-south traffic. Secondary locations simply handle local traffic, right? That's how this is kind of mapping out. Primary locations deal with the north-south traffic. So if I have one primary location, all the rest of my locations are secondary, like we're showing here, I have to move all of my traffic over to location A to send it out, and all of my traffic is going to come into location A and then will be distributed across my different sites, my different locations. Now, on a tier 0 gateway, I can configure all of my locations to be primary. All of my locations to be primary. Now, that could be a really useful thing in some cases, because this gives me local egress, right? I don't have to move my traffic up to my gateway instance in location C and then across the wire back to location A and then out. Well, that sounds awful great, doesn't it? I can send it straight out from location C. But what about traffic coming back in? Right? All primary locations means I have local egress, but it does not mean I have local ingress. I'm not I don't have a good way to bring traffic back into a given location if my workloads are spread across all my different sites. Because of that, in a lot of cases, and I certainly don't want to say all cases, but in a lot of cases, an all primaries deployment is great for maybe a campus deployment, or perhaps even a metropolitan deployment, depending on what kind of links I have across my metropolitan region. But an all primaries deployment is probably not something we're going to use for regionally disparate data centers, right? Where I've got 2 or 3 or 4 data centers scattered across a large region, right? Hundreds of kilometers or even hundreds of miles apart from each other. All primaries starts to not make as much sense because we don't have good control over how this traffic comes back into a given location if I'm spreading my workloads across all of my different data centers, right? So I've got to think about that cost of moving traffic from a location to another location on ingress in an all primaries deployment. It's all right. Just because we have an option doesn't mean that it's the right option for every use case. So when we start looking at our different gateways, right? When we start looking at different gateways and how we can put things together, I can have active tier 0 gateways in a primary secondary configuration. What this means is that all of my service routers inside a given location are active, meaning traffic coming up from my virtual machines can go to any of my local service routers. And those local service routers are then responsible for moving traffic, right? Moving that traffic to the active service routers in the primary location. So we've got a lot of different traffic flows that could be happening here as traffic could come up to, active 1 in location B over to active 1 in location A, or active 1 in location B to active 2 in location A, or so on and so forth, right? We see all of these different lines drawn in this diagram. Those are different possible paths from a virtual machine through a hypervisor to a service router, from that service router over to the active or to the primary site, and out to whatever external network you're trying to connect. So active tier 0 gateways in a primary secondary, that gives us a pretty flexible model. Now active in an all primaries, here we're showing a little bit different set of lines because all of my traffic can ingress and egress locally. Now again, like we were saying, this is not necessarily the answer for all of my data centers, but it's certainly something to be able to keep in mind and have in the back of our head. Now, my tier 1 gateways, this is a little different. It's a little different because all of my tier 1 gateways, first off, are active standby. I don't have an active option with my tier 1 gateways. But I also have an option to deploy a tier 1 gateway with no service routers, right? No services, which means only the DR component. My routing is completely distributed, which means my location, my location settings, right, primary or secondary, don't make any difference to the tier 1 gateway. So the tier 1 gateway is simply going to forward traffic north to the tier 0 gateway, and the tier 0 gateway is then going to be responsible for doing whatever it needs to do, like we just saw. Now, I could have services on my tier 0 gateway. My tier 1 gateway, I'm sorry. My tier 1 gateway having services means my tier 1 gateway has a service router and is associated with an edge cluster. And that means that all of my traffic goes to an active service router. Well, here now that we're federated, now that this tier 1 gateway is stretched, I have one active service router per location. So in that location, traffic is going to ultimately feed into that active service router, and then that active service router will be responsible for moving the traffic from a secondary location to a primary location. So here we've got active standby tier 1 gateway in a primary secondary config. So we're going to receive in location B, we'll receive traffic up at the tier 1 service router, and that tier 1 service router in location B, that secondary active tier 1 service router, is going to forward the traffic to the primary active service router in location A. primary active service router in location A will then forward that traffic up to the Tier 0 gateway. The Tier 0 gateway will process the traffic accordingly. So that's a quick overview of how my gateways are going to be stretched. We have communication that we need to enable between these locations for the traffic going from the secondary to the primary gateways, for example, as well as segment to segment traffic if we're moving traffic from an overlay segment, a stretched overlay segment in Site A to that same stretched overlay segment in Site B. We have our RTEPs, our remote tunnel endpoints. The RTEP exists on an edge and is used to send overlay traffic from one location to another. And we do that by mapping segments to a global RTEP, right? Remember that Global Manager has one thing in its head, right? It has a desired state that it pushes to the local managers, but the local managers are responsible for realizing that object locally, which means that when Global Manager pushes a configuration for a segment, it's going to say, I have this global VNI in mind. Well, every NSX manager is going to have its own VNI pool. So the segment ID, the virtual network identifier, is going to be different in Site A than it is in Site B, because local manager A and local manager B have different VNI pools configured. So we can't guarantee that from Global Manager we're going to call a common VNI. So what we've done to work around that is we have a global VNI that's used for RTEP to RTEP traffic. And that global VNI is mapped to a local VNI inside a given location at a local manager so that we can send traffic from segment to segment. This is actually in many ways similar to how the Layer 2 VPN works with our tunnel ID. It's not precisely the same, but the mapping is really similar. So we've got this global VNI, this RTEP VNI that maps on in any given location to some local VNI, and that's handled by the local manager. Right, all that mapping. That mapping is visible on the edge nodes where my RTEPs live. But traffic will go from location to location. It'll go from my ESXi transport node up to an edge. Right, the edge will transfer that packet across a new overlay tunnel from remote tunnel endpoint to remote tunnel endpoint, edge to edge. And then the destination edge will receive the packet, right? Take it, look at its mapping table, send it to the appropriate local subnet or local TEP or local VNI rather, in the destination site. So, here we kind of see that we've got this different VNI mapping going on, right? We've got our local TEP to remote TEP mapping available and visible on our edges. It's all managed by the local manager, because the local manager, again, is what assigns that local VNI. Now, since we're on the subject of overlay networks and mapping networks together, we can also bridge stretched overlay segments to VLANs now. Right? This is a relatively new feature that allows me to incorporate Layer 2 bridging into my larger federation strategy where I have a need for that. Right? So I can bridge something in a given location. I can bridge something across locations. I can bridge segments in both locations. Right? We have a lot of flexibility in what we can do. And so we can kind of see some of that here, where I've got maybe a stretched overlay segment and my remote tunnel endpoints, right, have these Layer 2 forwarder engines that we've got on our local edges for our local bridging. But we're going to use the same idea of a bridge profile and applying that bridge profile to a segment when we're bridging globally. The difference is we're going to build these bridge profiles and apply them to segments in Global Manager, not the local manager like we looked at in the logical bridging video, right? Same basic thing is going on here in Federation. We're just spanning that across multiple locations now. right? So we're going to learn those MAC addresses. We're going to communicate those MAC addresses through the control plane, just like we might otherwise. And traffic can forward from a stretched overlay segment to a VLAN. Something else really neat with Federation now in NSX4 is the fact that we have introduced TraceFlow to Global Manager, meaning that now we can actually trace a packet from one location across our RTEPs into another location, giving us an absolutely amazing level of visibility for traffic from location to location across our overlay networks, right? This is a huge visibility win. This is great for troubleshooting. It's great for all the same things that TraceFlow is useful for in a local environment. Well, it's available across Federation sites now, which is really, really, really powerful. This is cool stuff. So there's an overview of what we can do with networking in Federation. It's a high-level overview. It's a lot of stuff. I understand. I appreciate that. So, if Federation is a thing that you might need, this series of videos is great. It may also be worth looking into our multi-site networking with Federation course, right? We've got an entire course dedicated to going deep into Federation. So that might be of value. It might not. It depends on where you are. As it stands, we talked about overlay networks that are stretched and overlay gateways that are or not overlay gateways, tier 0 and tier 1 gateways that are stretched, and how we can bridge and how TraceFlow works in federated infrastructures. It's a lot of really cool stuff. Come back in the next video. We'll kind of do the same thing, kind of talk about a high-level overview of security in Federation. I can't wait to see you there.